Hello, welcome back. Today we're going to continue with F3, Chapter 4, Integration. In the last lesson, we talked about using substitution to perform integration in an easier way. We also briefly talked about some of the standard results, like here, 7 to 10, and how we can use common identities, usually trigonometry identities, to convert these into simpler functions that we can easily integrate. The general principle behind substitution is to make the expression a more straightforward expression to integrate. We also briefly talk about when the results are more complicated. And on your formula sheet, they look like this. They are given in differentiation, where I have pointed out to you. The bottom few look quite like the ones we need to integrate, like 7 to 10. Yes. And at the bottom of the page, second half of the page, you are given the integration formula directly. So you should be familiar. However, the ones in the integration, instead of 1, they give us a. When you substitute a equals to 1, you get back what you have on top. Okay. Today, we are going to show you through the examples 5a, 5b, 6c, and 7a, how to directly use the formula on your formula sheet. Now, the thing to note is when you use the formula, you need the coefficient of x squared must be 1. This is very important. So I'm going to cover how we convert the expression before you can use the formula. Let us go to 5a. Exercise 4C, question 5a. Integrate 1 out of square root 4x squared minus 12 with respect to x. Let us convert the coefficient of x squared into 1. Here there's a 4. So I will take out 4 such that we have this. Okay. However, the formula gives us a squared. So I'll try to simplify it into x squared minus a squared. And I will take out 1 out of square root 4, which is half. All right. Okay. Now it looks like this form. So we shall look at the formula. Here, the one I marked in pink. And it will be arc cosh. Okay. Let's see. Now, this is it. If you want, you can convert your arc cosh into, I'm sorry, there's no x here. You can convert your arc cosh into ln, depending on the requirement of the question. Okay. 5b. Integrate 1 out of 4 plus 3x squared dx. There's no square root, so we will check the formula sheet again. And it should be quite clear that we are using this one. First, we need to change the coefficient of x squared to 1. In the question, the coefficient of x squared is 3. So we need to deal with that. Take out 3. So this becomes 4 over 3 plus x squared. Yes? Yes. You can do it in a single step if you can skip. You can do this. Right. Take out 1/3. Square root 4 is 2. Yeah. Comparing with the formula, a is 2 out of root 3. You can rationalize it, but that's not really important. Okay. And then let's just apply the formula. There is a 1 over a, 1 over a, arc tangent x over a. Okay, and then plus c. Then we deal with simplifying the fraction. There you go. Next we have 6c. C is a definite integral, meaning there are limits to it. So you just have to do one more step after your integration to substitute in the numbers. If not stated, your angles, if any, will be in radians. Okay, so we need to first try to match it with a formula and then use the formula and then sub in the limits. I'm sorry, let it focus for a while. Okay, here we are. I will take out coefficient. Okay, 3. So that leaves us 7. Right? And minus x squared. Okay. And I'll convert this to a squared. So 1 over root 3 is a constant. It comes out. Integrate from -1 to 2. 1 over square root 7 square minus x squared. So our a is square root of 7. Right? From the formula, you should use the one with 1 over square root a square minus x squared. Here your a is root 7. Okay. That will give us arc sine. So 1 out of square root 3. You have integrated, use the square brackets to include your limits. Arc sine x over a is square root 7, -1 to 2. Do this, and then substitute the top minus substitute the bottom. Substitute the top, we get 2 out of root 7. Substitute the bottom, you will get negative 1 out of root 7. Then you should use the calculator. Arc sine is sine inverse. So you should have this function in your calculator. Also, please use radians, radian mode. Okay, and this is sine inverse. Include the negative sign. You should get some numbers. If you do it correctly and remember to divide by square root 3, you should get something like this. 368. All right. Okay. 7a. Integrate from 0 to 4 the expression 1 over square root x squared plus 16. This is easier because the coefficient is already 1. Okay, so very easily you can do. You can find out a plus 4 squared. And if you match it correctly with the formula is arc sine x over a from 0 to 4. Okay, I will do arc sine sub in 4 minus sub in 1, 0. Well, sometimes the question will ask us to leave in ln. If they didn't ask for that, you can definitely use your calculator and give a decimal. Okay. In the event they ask us for ln, you can use the formula also on your formula sheet, this one, to evaluate these two. So it will be ln 1 plus square root 2 minus ln 1. Ln 1 is 0. So finally, the answer is ln 1 plus square root 2. There you have it. I hope you are now able to use the formula directly if you do not need to use other methods. See you.